Alright, we appear to be making a video. I think it should be a video. It won't be something else. Yeah, pancake. It's not going to be a pancake. Anyway, so I thought I'd play some of this Robert Ritchie guy's video. And, I just stopped right where he started saying something. No, I don't go for that. Then Hoffaday brought up the Stern-Gerlach experiment, doing the spin stuff, and that might be worth doing some preliminary talking about. But this is one of those experiments where, unfortunately, I haven't found the 1960 version where they actually do the experiment. You can actually see the results and see the experiment done, which is a lot more helpful than when people animate it. And pretend they did things they didn't do. Like they use animations where they do it with electrons. Where did they do that? I haven't seen that. But anyway, I would sort of argue this idea that they can have, that there's something, a dipolar electron. I'm sorry, it doesn't make any sense at all. But a lot of what they say doesn't make any sense. So I'll play a little bit maybe of another video from a MIT professor saying some really funny things. Yeah, just hilarious. Anyway, about their own stuff. Yeah, like I said, well, it's. I mean, do what you wish. Fall for it. I mean, they're admitting it's basically garbage. They're they have no clue what's going on. And yet people believe this stuff like it's the truth. Okay, so now this is going to be on the subject of this magnet crap again, where I have pointed out over and over and over again that, let's see if I have where's my drawing? I lost it. It should still be up there somewhere. I don't know why I have misplaced it, but I have for some reason. You don't need this in the image. Thank you. Doing Linux, I'm trying to repair an old broken hard drive, trying to get the old files off of it. And so you go look that up online, file recovery. You get all kinds of stupid stuff that is supposed to work, but not working for me. Yeah, everything's crashing, so all the programs that are supposed to be able to do stuff, are just, hapless, hopeless, useless, and such. Alright, so let's transparency this and see if we can get away with this little trick. Okay, so here's the traditional picture of the magnet, and again, people think, and this guy's going to say, well, yeah, obviously there's something no, there's nothing moving. So the force that's coming off the magnet isn't doing anything in any of these directions. It's purely and completely straight lines of force coming off the magnet. Okay, just straight radial force, just like a light bulb. And the magnets of the iron that are now magnetized, they're compass needles now. Alright, they're little magnets. They're just lining up with the weight of the magnetic force. So obviously one here, if you put a compass needle here, what's it going to see? It's going to see a force here that this one end's attracted to, and a force here that the other end's attracted to, and this end is going to be repelled by this end, and this end's going to be repelled by that end. So it's going to flip to be south-north, the exact opposite, south-north. So it's going to have an opposite polarity, and it's going to be evenly pulled to the toward side, so that way it can't move this way and it can't move that way because of the balance between the two. So it just stays here as a compass needle and says, this is the magnetic influence I'm feeling. Now, if it was free to move, it would. The attractive force is stronger. The external pressure is stronger than the reflective forces, so it would move into this magnet. But the point is, it wouldn't change its alignment any, and it's not moving in a direction. It's not trying to get from this end to this end. It's not. There's no flow in here at all. And the same is true. Every single little compass needle will just line up with the direction of the influence in terms of its attracted end and its repelled end. So it's just compass needles lining up. There's no flow of any force, current, thing of any kind going back and forth directions. Nothing is going in any directions. Nothing's curling and coming in. That isn't happening anywhere in this system. Magnets do not waste energy doing silly things. Okay, they don't do that. Alright. So, now let's play the video. Yeah, that sort of works, actually. That transparency is pretty... I can go all the way to there. What the hell? You can't really... Well, I'll switch the window just to... Alright. Do it right, Gary. Okay. Switch the window. Alright, play the video.
It's the same field, whether it's at the North Pole or the South Pole. It just depends on the direction. Now...
No, so that's just not true. It's not the same field, okay? Clearly it's a charge field, so it's just as different as having... Man, it's just one of those days, unfortunately. Alright, I believe I'm back. Yeah, now I have to remember where I was. Alright, so there's no flows in magnets, and the two forces clearly are distinct. I mean, the two ends of the magnets have certain personality. The compass needle recognizes the difference in the personality. So, and again, the thing to remember, always remember, is when these lines are formed by these little pieces of magnetized magnets, these little magnets lining up, they're lining up in the opposite direction. So all these lines are north-south, not south-north. And they're therefore repelling each other. That's why there's lines. There wouldn't be lines here. None of these lines would exist. None of them. You couldn't see any of these lines if they weren't the same polarity. And the reason why, because they're the same, because they're lined up as the same magnets, they're repelling each other. So the lines wouldn't even be visible if it wasn't for the fact that they're not lining up alternately, north, south, north, south, north, north, south, south, north. They're lining up all the same and repelling each other.
Magnetic field has a rotational property, sure.
No, that's not sure. It's not sure at all. It's just a complete misunderstanding of how the thing works. There's nothing rotating. Nothing spinning, nothing moving. None of that's happening. It's like a light bulb. It's radiating a radiation. It's like radiation. It's coming out of it like a light bulb in straight lines. Nothing's flowing anywhere.
If you look at an object coming towards you that is rotating clockwise, if you look as it passes you and it's going away, it's rotating anti-clockwise, and that is a better analogy of what a magnetic field is.
It's not even close to anything that I could make an analogy out of. Can't even possibly make any sense. The north end is facing you when it's coming towards you over here. When it passes you, it's still the north end facing you. There's absolutely no difference. No, there's nothing moving here.
And what's happening here with all the iron filings is that they are intensifying or magnifying the magnetic field, and they're
exactly opposite to the magnetic field. So they're obviously, in a way, can't complement it because they're lining up opposing it. And the little south ends are, you know, I have to use the mouse, I guess. The little south ends of the compass needles are all pointing to the north end. And yes, that will be a complementary magnet when they actually connect to this magnet. Then it'll be an extension of the magnet in a way. But clearly when you bend that sideways, it becomes an opposite magnet, a magnet of opposite orientation. that's one way to say it. I mean, the line itself will become a magnet that is lined up south, north instead of north, south, north, south. That's why they're all repelling.
Trading like a corpuscular action on the field. They are concentrating into lines. So the regions around the iron filings have a weakened strength, and the lines caused by the iron filings have a more intense strength.
No, no such thing. As I just pointed out, it's just like magnets lined up the same way. They'll repel each other. That's what the spaces represent. It just represents the fact that those are magnets lined up, the same way. So their north and their south faces are hitting each other. See, the distance from the South Pole is the same from all these things. And so the point is their north-southness, their orientation of their orientation can't possibly be anything else but the same, because they can't change the alternation. Oh man, just shit day. All right, back again. Earth. It was Earth calling. Yeah, it's just stupid governments. Anyway, stupid people, stupid crap. Anyway, where was I? Let's play the video. I think I made my point.
As I said, it's not a fancy looking, what do they call it, hypertrichoidal. It's a double torus, and it's a totally false image.
Yes, their false image is false, but turning it into a two-dimensional swirl is just as bad as turning it into a three-dimensional swirl. So there's no swirling. It's all just an optical effect. It might look a little bit like something's trying to go somewhere, like it's coming out of the north end and it's hooking around, coming into the south end, but it's just the way it looks. It has nothing to do with what's causing that to look that way.
And that plane of inertia, that's just the magnetic neutral zone. Now,
well, it's not really neutral, but yes, obviously there's that point where it's the two dipole forces are perfectly mixing, where they're 50%, 50%, and that's the most mixed field. So obviously the more you mix the field, the more you turn it back into something like gravity. You take away the magnetism of it by the strength of it. So as soon as you dilute the blue with the red, you're diluting the power of the red to do something, because the blue undoes everything red does to electrons and protons. So if you want to affect an electron the most, you need pure red. As soon as you add any blue, you're polluting. It doesn't matter how much red you have, the blue will pollute it and it'll weaken your effect.
You've got to give the guy credit for trying the experiments, but he's misunderstood what he's saying.
No, there's no credit due to him, because he contrives experiments to prove points, and it's quote mining the experiments. You can see it in some of his experiments. They're just, crushes bottles against refrigerators to try to make the plastic dimple and pretend that somehow it's dimpling for some magnetic reason. He makes preposterous claims about what the ferrocell is doing when he's actually made them, and he actually knows that the LED lights are actually creating each one of these lines. There's a line for every single LED. The lines aren't some sort of manifestation of where a field line is. The lines are exactly where the LED tells the line to be.
First problem he's made there is he's attempted to illuminate a magnetic field with photons, with magnetic particles within a suspension. And what's happening is basically the same effect that you're getting here with these magnets.
It's really not the same effect, because he's obviously not also using dipole magnet. He's not putting a little bar magnet on the ferrocell, right? He's putting round magnets, magnets head first, tail first. So you're not getting this view of the traditional view of magnetism, you're getting the spread view, and the spread view is the only one that's going to create all those variant lines because it has a perfect symmetry. So when you put a magnet head down or tail down on top of the ferrocell, you're creating the perfect sun kind of pattern, and it's the perfect sun pattern that creates the curved lines, ironically.
Lines that are, like I said, they're not lines, these are just intensified by the iron filings. The iron filings, this is great to show kids and give them an idea what a magnet is and how the magnetic field is shaped on a bar magnet.
It really isn't great because they don't give you the correct understanding, so they do give you this misimpression. I wish when I was a kid somebody would have explained to me, no, look, you know how when they actually do the mathematics, and if you really think about it, no, this is just like a little red rays are coming out of one end in straight lines, and little blue rays are coming in straight lines out of the other end. And these are just pressure gradients. The more little lines you break, the stronger the pressure. And everything's just balancing on the fact that one kind of ray is attractive and one kind of ray is repulsive to each end of a dipole. And the dipole is just balancing between those two pressures.
But it's not a true representation. It's interfered with. The magnetic field is interfered with by the magnetic filings, just as Mr. Ken Wheeler's demonstrated.
Well, see, one of the facts is that the main magnet is so much stronger than the filing magnets that it's the dominant player in the sense that it magnetizes the iron filings. The iron filings are all magnetized in the same orientation, which means they end up repelling each other. So that's the procedure here. The amount of magnetism being irradiated by the iron filings is tiny compared to the amount of magnetism being produced by the bar magnet. So the iron filings really aren't in any substantial way contributing to the strength of the magnet. In a sense, they're dulling the magnetism's ability to propagate further. So they're making the magnet in some respects weaker.
Of the magnetic field interfered with by his particles in magnetic suspension. And then we have to examine a unique phenomena that gives him this crazy looking geometric pattern, and that is the photon is actually interfering with the magnetic particles in suspension and rotating, spiraling down towards the magnetic neutral zone.
No, it isn't doing any of that stuff. I'm sorry, it's just, that's rubbish. All the light's doing is running perfectly refractive angles. So all it's doing is the light hits the little bits, and the little bits are a tiny, tiny bit in a different alignment as you go further out, but they're all straight bits. So they're little, they're angular. So they don't do anything. There's no real curved line. There's just a bunch of different angles. So when you look at a different angle, you see the reflection off a different bit. So all you're doing is changing which bit you're seeing the light reflect off of. And that's all there is. There's nothing else going on there. It's just refraction, and it's not even complex reflection.
The nature of the universe is every particle wants to go from a high energy to a low energy. That's a fundamental principle of physics.
Well, whatever. It's not that they want to go. They obviously are being pushed. So it isn't about high energy. It's about pressure always. And it just gets pushed from high pressure to low pressure. When, you know, if there's a 90 mile an hour wind blowing, I don't say I want to go where I want to go west, young man. Yeah, no, it has nothing to do with what I want to do. I'm just gonna get pushed the fuck over there because there's more wind blowing one way than blowing the other way.
Everything wants to go from a high energy to a low energy, and what we're looking at heat.
I just used the word pressure. because the word energy doesn't really mean anything in a way. So if you just stick with pressure, voltage is pressure, so you can understand that. You can understand that quanta would be pressure. I mean, you know, you can understand using the word pressure, I think, much better than using a word like energy that's a little fudgeable.
I'll just go to another one. Here's, don't worry about the math, just look at the picture on the right hand side where you're seeing off the right hand thumb, you're looking at the electron flow direction, and you're looking at
and again, they'll never have any of that will ever be demonstrated. If they actually put an electron and dropped it, it's not going to move. It's not going to go in that circle. None of that's going to happen unless you push it, unless you give it acceleration. But it's not going to go on its own. You have to push it through that rotation. So again, the field has nothing to do with that image, in the sense that the field is actually red, black. It's like North Pole, South Pole, North Pole, South Pole, North Pole, South Pole. That's what's being radiated. And so again, the compass needles line up north to south. They're lining up because the field being radiated by that bar. So the field is coming out of the, just as these little loops are here. See these little loops? What's really happening is there's straight line force radiating out like a sun at on all these planes, and they're blue line, red line, blue line, red line, blue line, red line. And the compass needle is just going to line up with the fact that it feels the red pressure and it feels the blue pressure, just like the other magnet. It's just going to line up with that pressure. So they're showing you what a magnet, a dipole compass needle does. But if I put a dipole compass needle in that field that says ultra light, the lightest dipole I could make, it's not going to move in the direction of those arrows. It won't happen.
Well, the curl, you're looking at concentric circles of the magnetic field represented there by B. Don't even worry about that. There are no concentric circles. This is a pure magnetic field, and it just decreases in intensity with the inverse square law away from the wall.
Well, again, it's a pure magnetic field, but you have to understand that it's a dipole mixed field. So the little rays, like I said, are coming out. They're a million billion times smaller than we could see, kind of little rays, but I mean they're red, blue, red, blue, red, blue, red, blue.
Carrying the current. You can read that, you can phrase it. Don't worry about the math, just get the concept into your head. And
well, the picture doesn't give you the concept, because clearly it's not showing the radiation coming out of the wire. It's not showing the radiation.
Fortunate, Ken has highlighted some pretty crazy stuff, and he's gone down what I believe is to be a very erroneous path, and it's only going to end in a dead end, and I believe it to be totally false. And this is from what I know and what...
Right. Well, that's because he overtly admits he's doing metaphysics, you know, not real physics.
Studied, and I've been working with this medium for over 45 years now, and we don't...
Yeah, see, well, working with it just doesn't help. I could say the same thing 5 years ago. 5 years ago, I could say, yeah, I've been playing with electricity since I was 5 years old. I was sticking bobby pins in light sockets. So yeah, I could say I had 50 years experience. But the problem is if you accept what you've been taught, then you're in trouble, because they taught you wrong. They have gotten everything they could, when like I said, they've just gotten everything wrong. I mean, they picked pull instead of push. They put the plus sign in the wrong place. I mean, the wave and particle, they're choosing wrong again. They just keep making wrong choices. If they have a 50-50 choice every single time, they'll choose the wrong one. And so, yeah, until you realize they are wrong and that you have to go find the right answer. And that's what I did. I finally concluded this is there was a point, right? I heard about this two-slit nonsense and all this kind of crap 10 years ago, and I said, this is the silliest. I can't imagine people falling for this silly explanation. Now, even though when I was a kid, I said the stupid double wave thing explaining a photon had to be wrong because it's just too silly. It's too silly. Photons are dumb. They aren't complicated. How could they possibly believe a photon's doing whatever the fuck that is? This swerving in two directions. It's just silly. But I didn't have the, I didn't have the confidence, nor enough other evidence to sit there and recognize they could be completely wrong. I mean, I thought there had to be some grain of reason in science, but there's no grain of it. They're completely unreasonable. They'll just jump into the silly putty and swim in it. Photons are bent by gravity, even though, yeah, there's no real evidence that that happens. They're not bent by magnetism, something much stronger than gravity, yet we call them electromagnetic. Well, that makes zero sense.
Studying it, we just take it as it is. We work with it. We don't have to study it. We know what it does. We know how it works. We know how fast it works. We can measure it. There's been thousands of experiments done to confirm everything that I'm saying.
Yeah, well, it really helps to have the right answer, frankly. I mean, I'm seeing stuff so much clearer now about what the possibilities were and how things work, because I'm understanding where the force is coming from and where it's going. I'm not fooled by some notion that there's some other movement that's doing.
I just don't like people getting misled, and I especially don't like people telling everyone else they're an idiot when clearly the person is displaying false data and can't back it up.
Yeah, well, that's the real problem, right? If you're going to call somebody an idiot, then you got to back it up. You got to be willing to be tested yourself. And the fact that Ken Wheeler's a coward and calling dead people idiots, that's really low. You know, grow some balls, buddy. I mean, allow people to call you an idiot right to your face, and then you can defend yourself against the accusations when they start making them, that you're clearly a fraud and you're just deceiving people because you know better. You know the gimmick. He knows the gimmick of the ferrocell, and he's just pretending he doesn't.
Don't enter into an argument with anybody. They're right, everyone else is wrong. And they tell you they speak ancient Greek. Well, who cares? Or they speak or decode Prakrit or whatever language that is. Who cares about that? It's dead languages. It's not relevant.
Well, everybody has to have credentials to some extent. So yeah, this is kind of a bullshit argument. We should be arguing the argument, not arguing the messenger, the qualifications of the messenger. We should be arguing evidence, not arguing stories people tell. That's what it should come down to. So when I point out that there's no evidence for any movement in that field, it doesn't matter how small or light a thing I drop next to that conductor and it's magnetic or charged, it will not move in that direction. There's no evidence that there's anything moving in a swirl pattern around that conductor. There's no experimental evidence of any moving field except radial. Straight lines from the center.
Modern science. Just for your information, I speak numbers, I speak math, I speak binary, trinary, octal, decimal, binary coded decimal, hexadecimal, sexagesimal, and exponential. So if you want to argue with me, Ken L. Wheeler, I'm up for it. Not a problem.
Pi equals psi over di over phi. You know, he'll just you just end up wasting time throwing symbols. U0. You know, here we go again. Mu 0 and epsilon 0. Bullshit. Made up.
That's my view on this thing here. The most ridiculous picture ever put on the internet.
Well, it's not really, because it's just so obviously fake. I mean, it's obviously just it's a metal toy They put blue LEDs and red LEDs to make it look like it's warping light and it's causing phase shifts and all that kind of crap. But it's a toy. I mean, it's an interesting little toy, but it's just a toy.
And eat your words.
I mean, it's bad enough people think there's stuff swirling, but yes, it's really preposterous that they think there's stuff going this way and it's processing. So it's not even swirling this way. No, it's swirling this way and processing. What? Where? Where's one piece of real evidence that anything's moving? Again, you don't even see it in the ferrocell. Even with the little, nanoparticles of magnetic material, you still can't make them do any moving. Except when you change the position of the magnet.
I'm Rob Ritchie. Have a good day.
Yeah, well, I think my good days are long past. They're just tolerable now. So let's play just a little of this. So this is a guy, so he's doing a lecture. He's supposed to be talking about Stern Gerlach, but really there's no Stern Gerlach here. There's just the math. And it's just made up symbols for made up concepts. The new symbols. The mu here is for, the new spin function. And it's just they're wrong. Another one of their wrong guesses. That's all it is. And they'll contrive a whole big pile of frickin' math to justify that it's somehow rational when it's completely irrational.
Yes.
So where exactly does the fudge factor come from? Is it just merely because it doesn't really follow the classical analogy?
Right.
So where does the Bohr magneton come from? The guy sort of asked. Is it just an analogy? Something like that. So listen to this crap.
So the classical analysis is not valid. So it's pretty invalid, in fact. You see, the picture of an electron as of today is that it's a point particle. And a point particle literally means no size.
Right. Now, right to your face, they're saying something like this. When you know it has to have a size because photons obviously hit electrons. Clearly the force of voltage, the virtual photons, hit the hell out of electrons to get them to move. So, I mean, how can they possibly say it doesn't have any size? It's like, that's insane, isn't it? Isn't it just insane to say that? Because they know the virtual photons aren't bending to hit the electron. They're not moving into the electrons when they hit them. They're not doing any of that stuff. They're moving in straight lines and they either hit it or they don't hit it. But they don't bend into the electrons. There's no evidence that happens. That anything curves to go find the point particle.
The electron is not a little ball of charge. Otherwise,
no, it's supposed to be a pretty big ball of charge, obviously. See, I mean, just think about it. They're saying basically that an atom not only has an infinitesimally small nucleus, it has infinitesimally small, almost infinitely small electrons now. So yes, it's not 99.99% empty space. The whole fucking atom is now gone. Nothing has any space. You can't hit anything but space. I mean, it's just wrong.
have parts. So the electron is a point particle. Therefore, a point particle cannot be rotating and have a spin. So how does...
Yeah, and it also can't have dipoles. And it can't have any of this crap. So how can it have a magnetic moment when it's not a dipole? Oh, right, it can't.
Electron manage to have spin? That you can't answer in physics. It just has it.
So even though it makes no sense, you just said, so even though that doesn't make any sense, it can't possibly, it's not compatible with what we've already established as the truth, we believe it anyway.
Point particle that has no size can have mass. How do you have mass if you have no size?
Again, an argument nobody should even have. They measured the mass of the electron. I can show you the 1956 experiment. They measured it. How are you people saying these things? How do you make sense out of what you're saying? It has no mass, yet it's pretty freaking hard to move. You have to have a lot of energy to get it to go somewhere. I have to pump a bunch of voltage into it. I mean, their accelerators are, described in the whatever trilla watts of energy, right, or whatever they call it, the 10 gazillion bazillion electron volts. Why do they need all these electron volts if the thing is so frickin' light? Why don't they just blow on it? Why do they need 1 trillion electron volts to move it?
To the idea. The mathematics says it's possible. You don't run into trouble. So this particle...
Yeah, because the mathematics is completely circular. It only answers questions it asks. It only solves problems it creates. It's completely circular math. It can't go anywhere. You can't use it to how do magnets work? Well, this equation isn't going to tell you.
Has no size, but it has an angular spin as if it would be rotating. But it's definitely not the case that it's rotating. And therefore, this too confirms that it was a pointless idea to believe that it would be true. Nevertheless, kind of unit analysis or maybe some truth to the fact that quantum mechanics changes classical mechanics turns out that it's closely related.
So again, it's all just nonsense. I mean, really, he's just saying it's nonsense. You can't take any of this stuff seriously because it's self-contradictory.
Proton, for example, the magnetic moment of the proton is quite complicated as well because the proton is made out of quarks that are rotating inside, and how do you get the spin of the proton and the magnetic moment of the proton?
So again, a magnetic moment is completely dependent on some sort of dipolarity. You can't have a moment if you are negatively charged. So they're implying somehow that electrons move through the world just showing one side to them of themselves and saying, look, I'm negative, I'm negative, I'm negative. Yeah, I'm hiding my positive over here, but I'm negative, I'm negative. So I got a positive though. It doesn't make any sense. It's rubbish. It can't spin like a dipole. It can't be a monopole charge and then spin like a dipole.
Okay, the neutron that has no charge has a magnetic moment because somehow the quarks inside...
So again, they can't even figure out the obvious one, right? The obvious fact is the neutron, even though you called it a neutron, is clearly a dipole. It's neutral because it has plus charge and minus charge. It has an electron and a proton. The neutron is a dipole. That's why it has a magnetic moment.
In a way that their angular momentum doesn't quite cancel. So for example, the value for a neutron, I believe, is minus 2.78 or something like that. It's a strange number. Another thing that is sort of interesting, that it's also true, is that this mass is the mass of a particle. So if you're talking about the magnetic moment of the proton or the neutron, it's suppressed with respect to the one of the electron. The electron one is much bigger because actually the mass shows up here. So for a neutron or a proton...
Yeah, so he's basically just saying, they added a constant. They just changed the constant to identify the thing, so now the math isn't broken. There's no inconsistencies because they just used the constant to say, well, this math is this much off. So they just change the constant to the particle and then say they're doing something insightful, when no, they're just saying, oh yeah, electrons are very different than protons and they're different than neutrons. Yeah, we who didn't know that?
Magnetic moment is much, much smaller. So, in fact, for an electron, then, you would have the following.
Well, we won't do all this mathematical crap. So anyway, just such garbage. So I've seen a video where they demonstrate the Gerlach thing as a simulation with electrons. And I'm saying, how is that even possible? You can't have a plus and minus magnet that the electrons fly through without them going to the plus side of the magnet. So what's this a conversation about? It's obviously bullshit. Alright, so I don't know if I want to get into a whole bunch of other stuff. So yeah, until I find some really good source material. So if Hothaday has some videos that get to the real core of the Gerlach experiment, something that actually shows it being conducted, or something that has really reliable images of the results, or something where we can say, okay, this is what we're getting, this is what the experiment produces, this is what goes in, okay, heated accelerated silver atoms go through an aperture projected into an electromagnetic, an uneven electric field. So the assumption is when they go through an even electric field, they go through straight, indicating they don't have any magnetic moment, that they're perfectly comfortable lining and going. You know, they have no polarity. That would be the argument. Now, I don't know if that experiment's been done, right? I mean, but the thing that the first thing that occurs to me is, right, if you're using silver atoms, these are the same substance that is paramagnetic, which means it's conductive, which means you know, it's a conductor. Let's just say it's a conductor, which means we know that it is subject to the effects of Lenz's law. And although Lenz's law is always on a big thing, we know the atoms are what makes Lenz's law happen, right? So clearly the silver atoms are susceptible to being magnetically charged, if I can use that term, pressurized, magnetically affected, and that they will create a repulsive magnetic field to whatever influences them. So you could almost argue that as the silver atoms go into the experiment, half of them are affected by the North Pole first, and half of them are affected by the South Pole first, and that's why they're splitting directions. But who knows? Just, yeah, it really is. It really is a day of annoying people. Yeah, better end this video. A little bit of glitchy computer and such. So, it's probably enough anyway. And so, yeah, till the next time, interesting PBS space-time. Perpetual motion from negative mass. So, you know, the gibberish just goes on and on. Negative mass. Anti-mass. Pathetic. It just, I mean, they have no... They you know, they've gotten away with it, and so they think they can just say anything and they'll fall for it, and they're probably right. It's just pathetic.